disease spread, financial crises, cyber attacks. What do they have in common? They are some of the risks of the 21st century, and there is no more time to ignore them. As our world grows more interconnected, these seemingly unrelated risks have something in common. They can be contagious and spread across the connected world, like a disease. My name is Rafiar Karim, and in my research, I study a mathematical model that describes how these contagious risks develop. With a fundamental understanding of these risks, we can then use the model to estimate the size of the risks and prepare for them. What I do to make the model more effective is to add two components: generality and flexibility. First, the generality. We know that contagious risks spread over time. Think of the COVID cases in the Netherlands in the past year. Until now, people mainly looked at how risks spread over time in a specific location, but not at how it spreads across locations. My goal is to study contagious risks in both time and space. Think of the COVID cases in Europe, where the movement of people between countries makes contagion happen across locations. How to do this? Using mathematics. We can use the language of probability theory to model the spread across time and space. We can then look at the connected world as a whole and describe how everything is related within it. Second comes the flexibility. The model should be flexible enough to handle different types of situations. For instance, it may take weeks for a disease to spread over the world, hours for financial panic to spread across stock markets, minutes for a cyber attack to spread across information networks. How do I make the model more flexible? By allowing the parameters to stretch and bend more freely. With this flexibility, we can accurately estimate the size of the contagious risks in all sorts of situations. By adding this generality, the model becomes much more complex. In other words, the math gets more complex, and that is the challenge of my research. But it makes sense. Our connected world is more complex than it was a century ago, so our models should adapt to it. The financial crisis and the COVID crisis have shown that action comes after disaster. It should be the other way around. Action to prevent disaster. To summarize, if you are able to understand and estimate the risks of the 21st century, we can prepare for what is coming. Thank you.
What makes humans different from monkeys and apes? Proportionally, humans have the largest brain of any animal. But how did this come about? Humans share a common ancestor with monkeys, but they've evolved into a very different species. My name is Grace Farmelow, and I'm trying to find out why brain size and the way the brain works is so different between humans and apes. I'm doing this by looking at the building blocks of life, the DNA. Now, every cell in our body contains DNA, and DNA is a blueprint which holds the information needed to make an entire human. Many people think of genes when they think of DNA, but genes are not the whole story. So in fact, genes only account for around 1% of our cellular DNA. My research looks at the function of the other 99%, and in particular, how our genes are controlled by parts of this DNA. Now, let's think in terms of preparing a meal. If we consider the genes to be the list of ingredients, then the parts of DNA that control these genes would be the quantities and the method. A whole human requires an entire cookbook with many different recipes for a wide variety of dishes, which are all different despite many of them containing the same ingredients, rather like a cake or a quiche. And what's more, each human is made using a different edition of the cookbook, leading to variations and differences between individuals. Hair colour is a good example of this. Over time, some recipes will work better than others, and as a result, you'll see more of them in future editions. This is evolution. Successful variations will become magnified through the generations, and this can lead to the formation of a whole new species. And this is why humans and apes differ, despite sharing a common ancestor. I've been comparing human and ape DNA, trying to find out which genes and parts of DNA are vital for brain development, how they work, how they differ, and what they do. This is crucial to deepening our understanding of why the brain works and why sometimes it doesn't. My thesis looks into how these genes and DNA interact and what impact they have had on our brain evolution. By comparing human and ape DNA, I can refine my search and pinpoint which bits of DNA have had the highest impact in the human brain. With this fundamental research, I'm opening the doors for other researchers, giving them the tools needed to help develop treatments for devastating brain disorders like Alzheimer's.
Do you use your Instagram account to make yourself look a little better? Put a nice filter over your photos and flaunt your cool friends? For medieval nobility, there obviously was no social media to polish their public image. But they had other tools to do so, and my research is about a rather macabre one. In this time, the nobility used their tombs to shape public opinion. I researched the tombs of the Counts of Hainaut, Holland and Zeeland in the 13th and 14th century. These monuments are more than 800 years old. And this group of tombs is a rather problematic one. They're all gone. So before being able to research the tombs, I first had to reconstruct them. I used traditional sources to find out how they once looked. Take, for example, this list of payments to the artists who worked on the tombs. I found it in the Belgium archives. But I also used innovative research methods. I 3D scanned fragments of tombs and I've put those together again in a virtual reconstruction. So, what do these reconstructions tell us about the tombs as tools for propaganda? They depicted dynastic continuity and kinship. And I will give you a practical example of what that once looked like. Nowadays, millions of people are exploring their heritage. They search the archives for their ancestors, or they even use their DNA to track them. Medieval nobility was also obsessed with heritage and family trees. Of course, they did not know DNA yet, but they did believe that they inherited their noble qualities through a superior bloodline. On my medieval tombs, the family tree was depicted life-size. It took the form of actual statues of relatives. You could see who was who by the coats of arms that were placed around them. And what was most striking to me is that these family trees on the tombs are not always correct. They cherry-picked the most illustrious relatives and their important allies. So to put it in a modern context, they only chose their coolest Facebook friends. And for my counts, this was extra important, because they did not have an undisputed bloodline. They descended directly from a bastard. On their tombs, the family trees were super long. They went back up to 8 generations, so to the great-grand-grand-grand-grand-grand-grand-grandparents. And this was a smart way to divert the attention from their bastard ancestor. My research shows that the medieval nobles were not so different from us. Sure, they didn't have social media, but they used other clever ways to shape public memory. And my tombs are a very cool example of this.
Did you know that for some serious traffic offenses, you can get up to 6 months of prison time? Now imagine that they will double that, so it will become a year of prison time. Would that make you act differently? Would that prevent you from, for example, driving dangerously? Because lawmakers and politicians think that it will change your behavior. They assume that if they increase punishment, it will prevent people from committing crimes. But from social sciences, we know that that is actually not how it works. We do know that deterrence is something complex and that, for example, the certainty of punishment is more important than the severity of the punishment. So what does that mean, certainty of punishment? Imagine that here in Amsterdam, you're standing in front of a red traffic light. And if the street is empty, you might cross it, right? But if there's a police car waiting next to you and you know that you will get caught, you will probably wait until the light turns green. Kind of makes sense, right? So this leads us to the following problem. We have law that assumes that increasing punishment will deter people from committing crimes, while social sciences show us that it's not how it works. And this is not the only example. We have researchers within social sciences spending decades of research trying to figure out how law can and cannot change our behavior, and yet this knowledge is not even used in law itself. There's a gap between these behavioral functions we have in law and social scientific research on it, and I call this a misalignment. In my PhD project, I tried to figure out what this misalignment is and why it exists. Because only if we understand that, we can start to build the bridge. Why is this so important? We expect law to be effective, right? We expect law to try to keep us safe and to reduce misconduct. But how can law be effective if it doesn't use all this behavioral knowledge? Law needs social sciences in order to make proven to be effective laws. Because only with those effective laws we can start to work on a safer society.